The first example we did with the Riemann sum had a table of values, and we created the graph. We can also estimate the area under a curve using a Riemann sum if we are given a function. So in this example, I was given a quadratic, and it wants me to estimate the area of the curve from 0 to 2, and then it's going to give me a variety of Riemann sums. So the first one is going to be a left Riemann sum with 4 equal subintervals. So I've already drawn this. If you are trying to figure out, well, how do I know how wide each piece is? If I know the width, I can always divide. So if I'm setting this up, I'm going to say 2 minus 0 divided by 4. That's going to tell me the width of each individual rectangle. So I went ahead and set it up that way. So I've got 0.5, 1, 1.5, and 2. Those are kind of my points of interest. I already have the 0, 5 as well. So we're going to do a left Riemann sum. Now this is a little bit interesting because I gave you a y. I need you to write this as a definite integral, but it has to be some sort of dx situation. So we're going to go ahead and just put the function in there. We are integrating or approximating the definite integral from negative x squared plus 5, from 0 to 2, of negative x squared plus 5 by approximating a left Riemann sum with 4 subintervals. So what I need is I need the width, and lucky for me it's a universal width, which is nice, so it's going to be 1/2. And then I need the height on the left side. So I'm still going to go ahead and draw this for you, even though this isn't necessary. The left side is going to be here. So there's that first rectangle. And I want the left side of each rectangle to be touching the function. That's really what we mean by a left Riemann sum. We're supposed to be making 4 of these. So those are my 4. So I need the height. Here, see if I can make these a little bit darker. The height at these 4 spots, because those are going to be the heights of the 4 rectangles. So basically, I need y of 0, and then I also need y of 0.5, and I need y of 1, and I need y of 1.5, but I do not need y of 2 for this. So some of those are going to be pretty easy. You can use your calculator to get these. Y of 0 is obviously 5, but y of 0.5 takes a little bit of work. You got to think about that one a little bit. So this is going to be 4.75. Y of 1 is pretty easy to get. You get 4. And then again with 1.5 might take you a little bit of effort here. So you get 2.75 as being the height. So don't forget the 1/2 whenever you plug it into your calculator, and you get 8.25. I don't have a measure, right? I don't have a unit here, so I don't know if it's 8.25 feet squared or distance or miles. So I'm just going to leave it as 8.25. And is that an over or an underestimate? Well, I can tell that my left Riemann sum is over, and the reason is because f is now decreasing, or y. So we're going to say, even though it didn't ask for this, we're going to go ahead and address it because it's a highly tested AP topic. So this is going to be an overestimate because negative x squared plus 5 is decreasing.